Okay, so my name is John, Spring 2K19, Physics of Everyday Life. So today I decided that my topic would be rolling without slipping. It is something that seems counterintuitive to new students at first, and I've seen this example done once, but I don't think it's done enough. I've looked it up and I've never seen it on the computer. So I'll just get right into it. So basically, I wrote down a few numbers here. Rolling with slipping. So this would be a wheel skidding across. I'm not sure how well you can actually see that. So rolling with slipping, you have speed that the top of the wheel is traveling at, say, speed v or velocity v. The middle of the wheel is traveling at velocity v, and the bottom of the wheel is traveling at velocity v. That would be a wheel just skidding across the surface. Now, but when a wheel is moving, you have two velocities to consider. Now we have rolling without slipping. The top of the wheel is traveling in the positive direction at velocity tangential. The axis is actually still in this case, and then this part would be the bottom of the wheel would be traveling velocity tangential that way. So if you think of just something spinning, the middle is obviously like a CD. The middle is still, the top is moving that direction, and the bottom is moving this direction. So that seems pretty regular, pretty standard. So when something is doing both, you have, the rotation, like just traveling and it's actually moving. So when something does, I wrote down when something does one rotation, you have it would be you travel the circumference, right? So if something it rotates once, the real length would be the circumference here. So your distance traveled, your delta x should be 2 pi r, the equation of circumference. So your velocity would be your delta x over delta time, which would be equal to 2 pi r over the period. And if you want to rearrange that, you can do r times 2 pi over the period, and that is actually equal to angular velocity. So your final translational speed would be r times omega there. So this is the numbers way to go about things. If you want to look at things from a logical standpoint, then you would add up your rolling with slipping and rolling without skipping, your translational, and you come up to this. Now, this is what I'm most interested in right now. So this would be your total, and this is the product that students are always confused with. Like my explanation of the numbers was probably a little bit confusing there, and it's no slight to students. So what you end up getting when you add up these two things together is the top of the wheel is moving at twice your speed that the whole body is moving. The middle is moving at that speed that the body is moving. A car is moving at its speed. And the bottom of the wheel is actually not moving. So in a speeding car or a speeding log going down a hill, the bottom of it is not moving if rolling without slipping is occurring, which in most cases is occurring unless you're skidding all around. It's going to be rolling without slipping. So Professor John, how can you roll? How can you something not be moving and moving? So I'm going to show you right now. So I call this a walking demonstration. So when I walk here, I want you to pay attention to my right foot. My right leg is right here, and I need everyone to just pay attention to it. Right leg. Now I'm going to let you know when it's. I'm going to let you know when you actually really need to pay attention to it. Right now. 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 Notice that my right leg is moving ahead of my body and then moving ahead of my body when I was saying now. So it was moving faster than me. Now pay attention to my left leg this time. Still, 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 still. So when I'm walking, my whole body is moving, but I have one leg that's moving twice the speed, and I have one leg that's on the ground. And now when you put it all together, my wheels here, put it all together, my whole body is moving at an average of the two. One is moving double the speed and one is holding still. But my body is moving all at the regular speed. So just keep looking. One leg is still and one is going twice the speed and advancing by my body. And holding still again. So one real life demonstration of that, of showing that your legs can, and it's funny because people call their legs their wheels. You can show that movement happens even when something is holding still on the ground. You have your plant foot, and then you have your other foot that's advancing by at 2v. So hopefully that helps clear the air on rolling without slipping for people who don't know.